Hi, my name is Jake Cadet. I'm going to be taking the test today. I'm going to be doing the first question, which asks, for what angle of incidence is the reflected light completely polarized? Well, I'm going to do the calculations first before I draw the graph, but we're going to be using the Brewster's angle problem, which is tangent equals solid over air, or in this case, N2 over N1, which is, grab my calculator, just making sure we're recording, which is going to be tangent inverse of 1.73, which equals 60 degrees. And that's our angle. And basically, now turning that into our graph, we have a box and we have sunlight peering in through air, and it's at a 60-degree angle, which we just found, and our solid is 1.73. And the light is coming from the air to the material, with the solid being at 1.73 at the Brewster angle, and the light is polarized partially because of the 60-degree angle, which would answer our question for B, which asks us for this angle of incidence, the light reflected into the solid is it completely polarized, partially, or unpolarized? And it is partially because of that angle. So partially polarized. Be more descriptive. The reflected light is partially polarized. Wait, actually, let me think. Well, the reflected light is completely polarized, but the refracted light is not. Therefore, it's partially polarized. Going on to C. You shine a beam. You find the angle of incidence is 67 degrees. Reflected light. Find the index of the refraction of the glass. Okay, for C, again, we use the Brewster angle, but this time we are trying to find the solid, or N2. So tangent equals N2 over N1, which we would write as N2 equals N1 times tangent, which is just tangent of 67 degrees, which is 2.36. Which equals N2, or the solid. And before I make the graph, I'm also going to be doing D because they go hand in hand. And D asks, find the angle of refraction. And to do that, we are going to take the incidence and the refraction and set it equal fraction 90 degrees. And we have the incidence, but we don't have the refraction, but we're looking for that, so we're just going to put it as refraction equals 90 minus, and we're given the incidence, which is 67, which is going to equal 23 degrees. I'll put this like that, and the graph to go with this, I'm going to draw it as, so we have glass, air, okay, so glass, actually sit. it right here. Our angle is right here, so 67 degrees. And sunlight is right here, going in at 67 degrees. We found our n equals 2.36, or solid, sorry. And our refraction would be right here. And then we have air, and we have the glass. So the shine is unpolarized. It's unpolarized light from air into glass. Okay, yeah. Gonna have to make this as big. Moving on to E, which asks us, if so, what is the angle? Okay. Well, in this case, we were given then, okay. In this case, the light is polarized perpendicular to the plane of incidence, as it says. So some of the light is always going to be reflected at any angle. Therefore, at any angle of incidence. Yeah, okay. Yeah. So it's never going to be zero. Yeah. Yeah, okay, yeah, just making sure. It's never going to be zero because there's always going to be reflected light at any angle of incidence. Pretty sure. Yeah, I'm pretty sure that makes... I think because yeah. Okay. So therefore the answer is going to be there is no angle at which the light reflects. Throw that up here. Oh, moving on to F, which asks us if the polarized direction in the plane of incidence, is there an angle of incidence for no light is reflected from the glass? If so, what is that angle? Well, in this case, we are going to have an angle, and again, define that. We just used the Brewster's angle problem, and which is going to be tangent equals n2 over n1, and we're looking for the angle, so we're going to say angle equals tangent inverse, and we're given the n, which is 1.66, which is going to equal 58.9 degrees. And to make that into a graph, we're going to go box method again, and we have our angle of incidence, and we have our angle of refraction. Okay, this is dent flint glass, and our n is equal to 1.66. And the polarized direction is perpendicular to the plane of incidence. So, and then there's also airflow going on. Okay. Moving on to G, which asks us, find the polarizing angle in this situation. Unpolarized light propagating in the glass strikes the glass water interface. The light reflected back into glass will be completely polarized. Okay. Again, we're just gonna. This time we're finding incidence, but we were given the refraction, and of course it's going to be nice. So again, we use the formula to find incidence or refraction. So they equal to 90 degrees, but this time we're looking for incidence. It's going to equal 90 degrees minus, and we're given it's 45.5, which is going to equal 44.5. should be correct math from the head. And yeah. And our graph's gonna look something like glass, some water, our N, which are solid, but yeah, you know what I mean. 3, we have our light coming in at a 45-degree angle. I'm just gonna put it right here, 45-degree angle. And basically, the unpolarized light, how we're getting the glass, it's striking the glass-water interface and it's reflecting the light back into the glass, making it completely polarized. Okay. All right, thank you so much for watching. Have a good summer.